Now we are going to discuss about the peroxide effect. Peroxide effect also known as the Anti-Markovnikov rules. Anti-Markovnikov's rule. Okay, it is opposite to the Markovnikov rule. It is happening in case of peroxide, in the presence of peroxide. That's why it is called as the peroxide effect. Opposite to the Markovnikov rule. I will give the example, the best example. Same example will be take for avoiding the confusion. This is the unsymmetric alkene. It is called as the propene. It is react with the hydrogen halide. This is occur in the presence of peroxide. Opposite it is happen, I told. In case of Markovnikov, what happens? In case of Markovnikov's, what happened? Hydrogen went to that carbon which is having the more number of hydrogen. This is happen in case of Markovnikov's. But here it is opposite. Hydrogen goes to the doubly bonded carbon which is having the less number of hydrogen. Remember this. This is occurred in the presence of peroxide. That formula for the peroxide is ROR. This is happening due to this. Instead of going to that carbon which is having more number of hydrogen, instead of that it goes to that carbon which is having the less number of hydrogen. That's why what type of product it is produces? Opposite to the Markovnikov's. The product produces opposite to the Markovnikov's. Okay, here hydrogen goes to that carbon which is having the less number of hydrogen, means here. Then bromine, where it will become? Here. That's why what product it produces? Primary alkyl halide. This is only called as the Anti-Markovnikov's products. Anti-Markovnikov's product. Okay, opposite to the Markovnikov's. In the comparison, I will tell you what exactly it is going to be happen when the presence of peroxide and absence of the peroxide. I will write here. Same HBr, hydrogen bromide. I am writing two reactions. Here I will take the peroxide. Here I will take the no peroxide. What products it produces, just see. In the presence of peroxide, what happen? Hydrogen goes to that carbon which is having the less number of hydrogen here. And the bromine, where it will be go? Which is having more number of hydrogen. Bromine, opposite it goes. In this case, what happen? No peroxide, means according to the Markovnikov's. According to the Markovnikov's, what happen? Hydrogen goes to that carbon which is having more number of hydrogen. No peroxide, absence of peroxide. That's why hydrogen will be goes here. Then bromine here. Produces the secondary alkyl halide. When a secondary alkyl halide possible? When there is no peroxide. Peroxide is there, means primary alkyl halide. That's why what we will be called this product? What we are calling this product? Anti-Markovnikov's. This product is called as the Markovnikov's. Okay. Now we will discuss the mechanism. How the peroxide effect will be there. First I will write the peroxide structure. ROOR. It undergoes the degradation. I will write here degradation. Degradation is possible in many cases in the presence of light, in the presence of UV, in the presence of heat. All these are possible to undergo the degradation to produce what? Alkoxy free radical. Two alkoxy free radicals produces. Free radicals means what? On the carbon or any atom, when single electron is there, that is called as the free radical. Odd electron when it is present like this is called as the, this is alkyl, this is the oxy. That's why what it is called? Alkoxy. What? Free radical. How many? Two alkoxy free radicals it is going to be produced. That is the first step. Now see the second step. formation of the bromine free radical means, just see, alkoxy free radical react with the hydrogen bromide. I can write like this. Okay, react with what? Hydrogen bromide. Then what happen? This oxygen, one electron it is having, one more electron from here it will be take like this. 1 plus 1 total how many? 2 electrons. That's why it is what it is going to be form, R O. Then with the 2 electrons what it is going to be form? H. This is called as the ROH. Alcohol is going to be formed. Okay, how it is going to be formed? By this free radical single electron, it take the single electrons from here. That's why it is forming the alcohol. What it is forming? Alcohol. Along with that, what it is going to be produced? Bromine free radical. This is very important. This is the bromine free radical. How it is formed bromine free radical? Because this is having only one electron, this one. That's why it forms like this. This is called as the free radical. Okay, this is second step. First step what I told, alkoxy free radical happens. Second step what I told, alkoxy free radical react with the alkyl halide. That's why what it produces? Bromine free radical. In the first step alkoxy is the free radical, but in the second step bromine is the free radical. No, third step. Third step is what? Formation of primary and secondary free radicals. See, this is very important. Formation of the primary and secondary free radicals. Now I will show you. Now I will take the alkene. Alkene means same propene. Now which will be? Bromine free radical is formed already. Okay, this free radical, it is going to be produce the two types of products. Once it is attacking on this carbon, another time it is attacking on this carbon. When attacks on this carbon, what happens? Just see, this is first attack, this is the second attack. First attack I am writing. See, first attack what it is telling? Bromine going to this carbon. Okay, attacking on this carbon. Already one electron is there. Here 2 electrons total. Okay, it required 2 electrons for the formation of the bond here. How many electrons? 2 electrons. 1 electron with the bromine. Okay, here 2 electrons it took for the formation of single bond. 1 electron bromine it will be have. Another electron and from the double bond. Okay, that's why here only 1 electron is remain. See, 1 electron it is taken away with this bromine here. 1 more electron it is going here on this carbon like this. Carbon free radical present on which carbon? This is the first carbon, this is the second, this is the third. Second carbon free radical is present. That's why what it is called? Secondary free radical. Another product you can see here, bromine goes to here, the attack on this carbon. When attack on this carbon, bromine will be take 1 electron from this double bond. Here 2 electrons total. 1 electron from the double bond, 1 electron with the bromine. That's why it forms the bond here. Then here on this carbon, 1 electron will be remain. On which carbon it is remain? This is the first carbon, this is the second, this is the third. And the first carbon free radical is there. That's why what it is called? Primary free radical. Because due to the attack of bromine free radical. Okay, this is the free radical, bromine free radical. Bromine free radical attack on this carbon. means first carbon. This is the first, this is the second, this is the third. When attack on the first carbon, what happens? Here one bromine electron, already bromine have one electron here. One more electron it is taking from the double bond. Okay, that's why here two electrons. See, one and two electrons. That's why here remain only one electron on this carbon because one more electron given to bromine. Okay. That's why it is two types of free radical will be formed. This is called as the secondary. This is called as the primary. Now tell me, which is more stable? Secondary free radical more stable than the primary free radical. You have to be remember this. How? Secondary carbocations more stable than the primary. In the same way, secondary free radical more stable than the primary. See how it will be going to form the propyl bromide. How it is going to be formed? Here what we have to be take? Primary alkyl halide? We have to take primary or secondary? Secondary. Why? Why we have to take the secondary? Why we have to take the secondary free radical? Why we have to take the secondary free radical? Here it forming the secondary, here it is forming the primary. Okay. Now what I told? Secondary more stable than the primary free radical. That's why I will take the secondary free radical. This is secondary free radical. Now it is going to be react with the hydrogen bromide. See what happens. Here already one electron is there. Here already one electron is there. One more electron is here. That's why this hydrogen it come with this electron here. Okay. Here two electrons with that. What product it is going to be formed? Okay, one electron taking from here, hydrogen bromide, one electron it is present in the secondary free radical with these two electrons. Okay, hydrogen going to be form the new bond. That's why see here CH3 CH2 you can write like this also, CH3 CH2 CH2 Br means what it is going to be formed? Primary alkyl halide. Why primary alkyl halide? Bromine present on the first carbon. That's why it is called as the primary alkyl halide. Okay. This is opposite to the Markovnikov's rules. Exactly opposite to Markovnikov's rule. Reason is what? Reason is secondary free radical more stable. That's why we are taking the secondary free radical. In the final step, they are going to react with the hydrogen bromide. In between hydrogen and bromine, two electrons are there. Okay, the two electrons forming the new bond with the hydrogen here. Okay, this will be forming here. Then producing what? Primary alkyl halide. This product only we are calling as, this product also called as the Anti-Markovnikov products. Okay, thank you very much. Please don't forget to subscribe. Don't forget to like also. Okay, this is small help I need from you. I know that many people they are not going to be subscribed because they are giving money from their packet. That's why they don't subscribe. If they will be subscribed means I will become a crorepati within for only their one subscription. I will become a crorepati. That's why they don't subscribe. Please, we are the human being. Subscribe it. Okay, I will feel more happy and I am very thankful to all you people. Okay, thank you very much.